A freshly pre-trained language model is a brilliant text predictor, but it's not an assistant. It doesn't reliably follow instructions and it has no sense of what's helpful or safe. The technique that bridged that gap and made models like ChatGPT usable is RLHF, reinforcement learning from human feedback. Out of pre-training, a model has only learned one thing: predict the next token, ask it a question, and it might continue with more questions because that's what text on the internet often does. It's knowledgeable but unaligned. It doesn't know it's supposed to be helpful, follow your intent, or refuse harmful requests. We have to teach it that. The first step is supervised fine-tuning. Humans write high-quality examples. Here's an instruction and here's a good response. The model is fine-tuned on thousands of these pairs, learning the basic shape of being a helpful assistant. Answer the question, follow the format, be useful. It's a strong start, but it can't cover everything. The trouble is, good is hard to define. What makes one helpful answer better than another helpful answer? More clear, more honest, better toned? You can't write that as a rule or a loss function, but humans know it when they see it. So instead of defining quality, we measure it by asking people. For the same prompt, generate several responses and show pairs to human raters. They don't score them, they just pick which one is better. Do this across thousands of prompts and you build a big data set of human preferences. This answer beat that one. Comparisons are far easier and more consistent than absolute scores. Now the clever move: train a second model, a reward model, on all those comparisons. Its job: look at any response and predict how much a human would like it as a score. We've turned fuzzy human judgment into a number a machine can optimize. The reward model is a learned stand-in for human taste. Finally, the reinforcement learning. The language model generates responses, the reward model scores them, and we update the language model to earn higher scores, typically with an algorithm called PPO. Round after round, the model shifts its behavior toward what humans rated highly. It's learning to be the kind of assistant people prefer. But there's a danger: chase the reward too hard and the model goes off the rails, producing weird text that games the score. So RLHF adds a tether, a penalty for drifting too far from the original pre-trained model. Improve by human preference, yes, but don't forget how to write. Reward on a leash. Put the three steps together: supervised examples, a reward model, and RL, and a raw predictor becomes an assistant, one that follows instructions, stays on topic, admits uncertainty, and declines harmful requests. The aim is often summed up as helpful, harmless, and honest. This is the step that made LLMs feel like they get it. RLHF works, but it's a complex, finicky pipeline. So a simpler alternative emerged: direct preference optimization, or DPO. It skips the separate reward model and the RL loop and tunes the language model directly on the preference data with a single, more stable objective. Same goal, aligned to human choices with far less machinery. RLHF is really about alignment, making a model's behavior match what people actually want, not just what was statistically likely in its training text. It's the difference between a model that can write anything and one you trust to help a stranger. As models grow more capable, getting this right only matters more. It's not perfect. The model can learn to please the reward model rather than truly be better. Reward hacking, like writing long, confident answers that only seem helpful. And the model inherits the biases of whoever gave the feedback. Alignment is only as good as the humans and the signal behind it, an open, active problem. So that's RLHF: teach by example, learn human preference as a reward, then optimize the model to match it, turning a text predictor into a genuine assistant. It's the alignment step behind every chatbot you use. Next time, the engineering that makes these giant models small and cheap enough to actually run: quantization and distillation. See you there.